Hi everyone. Today we will be talking about basics of object-oriented ABAP. I'm doing this session because most of the freshers who are connected with me are requested for this. So let's take a deep dive into the theory of object-oriented programming. Now, the object-oriented concept in SAP started with the business object repository, and these business objects are accessible using the Tcode SWO1. Okay, business objects are used in workflows, and they also have BAPI methods which are called within the workflows and some other places as well. And these BAPIs are also used individually recently in like most of the places, all web UI and OData surface and other things, etc. Later, SAP switched the object-oriented their paradigm from these business object repositories to ABAP classes, which are available in Tcode SE24. And now these objects are extensively used. So let's take a deep dive into these objects, which are defined in SE24 Tcode. Now, what is an object? The object is anything which you can see, hold, or feel in the actual world. So even your dreams can be categorized as objects, and they can have their own methods and attributes, etc. So that is why I use the word feel. Objects have states and behaviors, and let's take an example of an employee. Now employee will have a number, employee number, name, department, age, designation, etc. So all these are states of the object employee. Now it will have behaviors as well. The employee will get recruited, the employee can get transferred, the employee takes leaves, the employee gets salary, etc., and so on. Now, what is a class, attribute, and method? Now, class is a template that describes the object state and behavior. Okay. Now, attributes are the various states of the class. So, attributes are basically the variables which will hold the values for that particular instance of the class which it is being generated. Next comes the methods. Now, methods are the various behaviors of the class. And typically what we have seen is that the code which you generally write in the SE24 class is for these methods which describe the various behaviors of the object or the class. Now we will take a deep dive into the concept of abstraction, which is one of the core concepts of object-oriented programming. Now, data abstraction is the mechanism of exposing only those interfaces and hiding the implementation details from the user. So, what happens is when you are defining an object method, only certain parameters or whatever input parameters are exposed. Like you take it inside and you expose whatever is the output to the outside world. The outside world does not need to know what all code or lines of code which you have written within that object. Now it is similar to the performs or routines which you have in a SE38 report basically, and also to function modules, also to modules or in the module pool, etc., and so on. Now, next comes the example which we will be implementing in our practical sessions. So we have considered a super class, which is a ZCL parent class, and this parent class will have two child classes, ZCL child class and GCL child class 2. And we will be talking around along the coming videos about these three classes. Now, let's talk about encapsulation. Now, if you know everybody from your, like maybe when from your teen or something, you always have a medical capsule when you're not feeling well. So, and once the capsule goes in your stomach, it explodes, and whatever is needed is, provided to you as a medication. So, on surface, you see whatever is the content in a plastic or whatever soluble material which is covering that. So, encapsulation is also similar to that. Now, in case of object-oriented programming, the concept which binds together the functions and the data, and it keeps both of them safe from the interference or misuse. So that's what I said. Like I gave you an example of capsule. In a capsule, the medication is wrapped inside the cover. So similarly, encapsulation, it encapsulates the covers or wraps the functions and the data within the object, and it keeps it safe from the outside world for misuse. We already saw that the global variables in the function module can be changed. You can check that video. And in case of object oriented programming, it has a better functionality of avoiding this misuse of the objects, data, etc. Now there are three aspects. One is public. So you can have public attributes and methods, and they are available to the outside world. Then you have protected, wherein the protected attributes and methods are available to the self class or to the subclass or the classes which are inheriting those that class. And there is last, which is the private, which is only available to self, which means whatever you declare it as private will be only available to that particular class. It won't be available to the outside world. Now let's go to the next slide, wherein we have a parent class, GCL parent class, and it has attributes and methods. Now, the public attributes and methods, they can be accessed from any other SE38 report. We have in the video, we have an example wherein only the public method and attribute is accessible. Now we have used the SE38 report, but you can call it from any other executable object. Then comes the protected methods and classes. Now these protected methods and attributes are available within the class and the subclass. So we have given an example of the subclass ZCL child class, which can access the protected methods and attributes of the parent class. And next comes the private, which can be accessed only within the class. So if you see the hands-on sessions, you can see the examples and practice it accordingly. Now, next one is the child class, ZCL child class. And if you see, the protected methods and attributes of the super class can be accessed within this child class. In the the practical videos, you can see this. And then we have the public methods and attributes of the super class, which can be accessed from the SE38 report or else within the subclass as well. The next topic is inheritance. The inheritance is a concept of passing the behavior of the parent to the another child class. So it's not just behavior, some attributes also, whatever is possible, can be passed on to the child class. Now, inherited methods can be redefined in the subclass or the child class. Now, it is up to the child class to reuse the parent class properties, and in addition to your own additional, behavior which you have. So we will see that, if you redefine a method in a child class, you have option of calling the parent class method within that, and then it can be followed by your own custom code which is specific to the child class, and not just followed by within that method. You can call the super class method anywhere in between the execution, and then it will behave accordingly. So that example we will see in the hands-on video. Next is polymorphism. Now you call a method using different objects based on which object it is pointing to. Now this is one of the peculiar behaviors of object-oriented programming. If you use a function module, usually what we have seen is that when you do call FM, instead of having the function module name in single quotes, you pass it using a string variable and you dynamically call different function modules. Similar to that, you can do the same stuff using polymorphism. and we will see the examples of it. Now, in case of polymorphism, there are two ways you can achieve the polymorphism. One is between the superclass and the subclass, and the second one is using the interface and the classes which implement those interfaces. Now, in case of superclass and subclass, the superclass will point to the subclasses instances, and the superclass variable will call the method, but on depending on which class it is pointing to, that method will be called. Now we have to note this one point, which is important, that when you are using polymorphism, the parent class can, or the superclass can, only call the methods which are common between the superclass and the subclass. Let's say if you have defined some additional method within the subclass, you will not be able to call that additional method because it is not defined in the parent class. Now, in the practical example, what we will do is we will have three variables, which will, each of them will be pointing to the parent class, the child class, and the child class 2. And based on the which class, subclass, the parent class variable is pointing to, that particular subclass code will be called, and we will see it in debugging how it works. So that is how the polymorphism example we will see how it works. Next case in polymorphism is the common interfaces between multiple classes which implement them. So instead of pointing to the parent class, you can also point to the interface which is common amongst those classes which are implementing those methods. And the interface will point to those classes, and based on which type of class it is pointing to, the methods, the common methods will be called accordingly, and that particular class implementation will be called. So this is also one way of implementing polymorphism. So thank you for